Okay.
All right. Hello, everyone. How we all doing today? We are back at it here again, and today promises to be an amazing day. Of course, we've been looking at an awesome topic from our last session, and this week we intend to also continue from that awesome topic we began. Also with me here, okay, maybe I should go with introducing myself first, and then I introduce the experts we have in the house for today. My name is Promiso Wachko. I'm a Microsoft MVP as well as a senior DevOps engineer. Today, I have with me some awesome people in the house. I call them awesome because I think I've been working with them for a number of years now, and I have seen them in the real life, troubleshooting scenarios, and how they work their magic when it comes to DevOps engineering itself. So the first person I'll be introducing for today is none other than Chidebere Ugu. Chidebere Ugu is not just a senior DevOps engineer, he is
Yeah, of
also
course.
an awesome Microsoft engineer that he's worked with Microsoft for a couple of years. And this time around, I think he has turned around the atmosphere, I would say, of cloud engineering and DevOps engineering because of some of the projects he has found himself in and he has worked on. Sometimes I actually try to spend some time, you know, trying to gain some knowledge from all the projects I've seen him working on. And sometimes I'm like, oh, Chidebere, you have to come teach me one or two things. So yes, so we have in the house today Chidebere. Chidebere, do you have one or two things to say before we proceed?
Okay. Thank you, Promise, for this awesome introduction. So, as Promise rightly said, my name is Chidebere Ugu, Senior Cloud Infrastructure and DevOps Engineer. So, today we'll be having a session on Azure Kubernetes Services, and then we'll follow that up with other series. Thank you.
Awesome, awesome. Thank you very much, Chidebere. I also have in the house here with me one of the senior experts. I would call him Ihe Nacho, but for short, people mostly know him as Nacho, right? Nacho has been a colleague of mine right from the days of Microsoft, where we used to troubleshoot things, we used to share knowledge together, tackle difficult challenges, just so that we are up to date with the recent trends. Um, Nacho has gathered, if I'm not mistaken, over 7 years in this field, right? And he keeps on still doing exploits in this field. So, Nacho, do you have one or two things to say before I proceed?
Yeah, it's a pleasure to be in the house. Also have the privilege to share experiences and also gain some useful ones along the line. Yeah, thanks for joining us as well in this journey.
Awesome, awesome. Thank you very much, Nacho. Yes, like I said, today is a continuation of the session we began last week. And one of the important things we want to do today is we promised you an actual live demonstration of what we started last week, right? But just to recap and to give you an overview of what we started, I would proceed to share my screen and just give you a few tips, and then we proceed with the actual demo for today's session. Okay, let me share my screen. All right. Please let me know if you are able to see my screen.
Yeah,
All
it's
right.
coming up.
Awesome.
Yes, I can see
So
your screen.
thank you very much. So, just like we started speaking last week, we were focusing on automating AKS cluster deployments, and we wanted to really break down how you could actually go about, creating your cluster, the various tools you could use to create your cluster, and how you can automate the deployment. So, it's a beautiful thing to automate. I know we all know that, right? And automation is I will call it the core backbone of being a DevOps engineer. I don't think you can actually be a DevOps engineer without knowing how to automate. So one of the things we are going to show in our demo today is how do you automate tasks like this, especially in if you're dealing with tools like let's say your Azure DevOps pipeline. How do you automate tasks with that? If you have to write like a bash script, you have to work with Terraform, you have to work with Bicep, or you have to work with PowerShell, for instance. How do you automate things like that? And of course, I told you we have some interesting, wonderful speakers in the house today to also go along that line. Also, I wanted to give a brief overview of why we want to focus on automation today. One of the tools we are using for this demo session is going to be Terraform. And as you all know, Terraform is an awesome tool which people use to create infrastructures in their various cloud environments, right? So you want to be able to understand how Terraform works. You want to be able to have the basics, the basic knowledge of how can you set up your Terraform file, the providers, the main.tf. Maybe if you have some local variables you want to work with, or you want to be able to manipulate variables, in your Terraform script, how do you go about that? That's something we'll take a close look at. And also, just as you know, right, when dealing with Terraform, I think there are very key things which you really have to see, which is, I would say, one, you obviously have to have the software installed, right, on your system or whatever platform you're using. And then at the same time, you need to know what are the components expected in your main.tf file, in your variables.tf file, and what are the contents expected in your output.tf file. You understand? Having an understanding of these things gives you like a background knowledge on how you should proceed with Terraform, right? So this is one major tool that people in the DevOps field have to really, really understand. And I want to try as much as possible to see how we'll break that down for you. Um, One of the other things we would be looking at is scaling and updating your AKS clusters. This is something you would also get to see in our session today. And basically, the idea of this is when you're dealing with certain workloads, right, you want to be able to understand how to ensure that your cluster is able to manage those workload effectively. Talking about, let's say, your nodes. How many nodes do you have in your cluster? What is the capacity or configuration you've set up in your cluster to ensure that you are able to successfully run, let's say, let me for instance, 150 pods, right? How many nodes do you know you need to have to ensure that you can run 150 pods, for instance, right? Let's say you have over 60, or let me say 27 deployments, and then you want to be able to ensure that you're not dealing with issues relating to CPU, you're not dealing with issues relating to what's it called? You're not dealing with issues relating to let me say scaling, or let me say your pod or your node crashing. You understand? These are basic things that as a DevOps or a cloud engineer, you should know how to manipulate. Resources, when it comes to resources, they are very, very key to your cluster being able to run successfully. I mean, you don't want to be running a production workload and at the end or at the middle of your workload running, or maybe your customer is trying to connect, and then you find out that, oh, your pod is no longer running, it's crashing. Why is it crashing? Because, oh, there's so much loads on the node and it doesn't have the required resources for it to be able to run. So that is something you really, really want to avoid. You understand? Okay, all right. Without wasting so much time, I think let's dive deep. Let's go dive into the demo session. And to take this up, I'll be calling on my colleague Chidebere Ugu. Like I said, he is a sound expert. And if for any reason you have any questions, please don't hesitate to put them in the chat, and we are here to answer your questions. All right, Chidebere, please can you proceed?
Okay. Thank you, Promise. So at this juncture, I'll be sharing my screen, and then I'll give you guys a walkthrough of the code structure we have, and then we'll try two deployments. One we do a manual deployment, and the second then we go to pipeline and deploy via pipeline as well. So let me know when you see my screen. Yeah, share my entire screen. Yeah, tell me when you can see my screen.
Yes, I'm able to see your screen, Chidebere.
Okay.
Yeah, I can see your screen.
Okay, good. So what you're seeing here is just a basic structure, a basic structure of Terraform to deploy Azure Container Registry, which will be holding images, because probably on subsequent topics we'll be deploying some application, pulling application images from Container Registry to the AKS cluster we're about to deploy. So this structure is just to deploy AKS and ACR, and then I will go through explaining each of the code structures. First, let me minimize all this. First, we created an environment just like a folder structure. There are different ways you can put up your folder structure that will help even subsequent engineers or any person that might inherit your code be able to manage it. One is putting it in different environment structures or in modules. So, but for the purpose of this, we are not specifying that in modules because the infrastructures we're about to deploy are not just many. But in a situation whereby we want to use a modular approach, what happens is just that maybe under here we can create a new folder called AKS, and then the second one called ECR. Then on the main.tf, you can call the module like you share module. Yeah, that's AKS module. Then you call the folder structure, that is the AKS slash the name of the file in it. So this is just a basic way to call modules, assuming we have different kinds of infrastructure, let's up to 10, 20, or 30 infrastructures, and we want to use module aspect to make that maintainable. But so far we are not using module, so I'll go straight to individual files and explain what we have in there. So first, for you to be able to deploy infrastructures using Terraform, you have your main.tf. Your main.tf specifies either the particular resources you want to deploy or the modules where those resources have been declared. I will explain all those resources that we have on this. And then, aside your main.tf, you have your output. The purpose of the output is to extract some details from those resources that you are about to deploy, so that if maybe there are subsequent resources in a situation whereby you are deploying AKS, you are deploying ACR, and then you want the AKS to make reference to either the ACR ID, you have to output the ID of the ACR, and then the AKS will be able to pick up the ID from your output. So another part of the folder structure is your providers, where you define the API references or the necessary providers that will read for, that is needed for your configuration to work. So coming to this backend.tf, backend.tf is a kind of a reference to a storage account that holds your TF state. Because in Terraform, unlike Bicep that just manages the state configuration by itself. In Terraform, you have to provide the reference to your state configurations. So probably if you are deploying to either of your cloud desired cloud environment, in this scenario we are using Azure, you create a storage account, and then inside that storage account you create a container that will hold your TF state images. So to make reference to this, within Azure, I will show you a quick overview of how to get these values that is being referenced in your backend.tf. So within your Azure interface, yep, can go to a resource group. We notice that from here, we have reference to the resource group called demo. And inside this resource group, we have a storage account named this. And then inside this storage account, you have your container and your key. So this is the demo resource group. And then we can search for storage accounts. So in case you have multiple resources, you can just search here for easy access. Yeah, this is the storage account. And then here is the container. Yeah, this is the container, and here is the key. So just let's confirm all the references from this backend.tf. So we have the resource group demo, we have this storage account, then we have this container name, and then this is the key, which is this. So once you have made reference to this, immediately run your deployment either via manual deployment from your VS Code or via pipeline. Your TF state or the configuration will be stored in this particular um, container, and then any further modifications you want to make will be referenced within that TF state. So the next file, important file here is the main.tf, which defines the resources that we are to deploy. First, we are deploying Azure Container Registry and the AKS Cluster, but there are some other dependencies before we were able to deploy these two main resources. One is a resource group, which will contain uh, these two resources, the ACR and the AKS cluster. So we can make reference to an existing resource group like the demo that we already have, or we can create a fresh resource group. So in this situation, here is a reference to creating a new resource group. So the resource, you call the resource, and then the Azure Resource Manager that is responsible for creating that particular resource. So we have different resource managers parameters or reference to particular resource that you want to create. So for this, you have Azure RM resource group. Then you can name it anything depending on the naming convention that you have. In some organization, you have a standardized naming convention. You have a naming convention, then you specify these two parameters, the name and the location. You can specify multiple other parameters depending on the configuration you have in place. So, but these are the two major parameters, the resource group name and then the location where it will be. Then the second resource set that we're about to create is a role assignment. So in that situation, we have not even gotten to the ACR or the AKS, but the essence of this role assignment is when we are going on the second tutorial on this, trying to pull an image from Azure Container Registry to AKS, there is a need that to have a service principal that will be able to have permission for the AKS and the ACR, and then be able to pull the image from Azure Container Registry and deploy that to AKS. So that is the essence of creating a role assignment. And then the name of the role assignment is ACR pool. So this service principal will be able to pull an image from Azure Container Registry and then deploy that to AKS because of the access given. Then you see the scope. The scope of this role assignment is Azure Container Registry, which is this Azure Container Registry dot this ACR dot ID. This ID is outputted already here within AKS ID. Yes, here. This is the output. And then the reference to this Azure ACR.id. Then the name of the row is ACR pool. Then this is the service principal. So the service principal will be automated, and then what we just need to get is the ID, the object ID of the service principal, and then skip service principal Azure Active Directory check true. So during the deployment of this resource, if you don't want to take a longer time for Azure RM to verify the service principal is role assignment because of the fact that these resources have not been created yet, then you can skip the role assignment. So skipping it to true will keep that check out of it. And then once these two resources are created, this is a situation whereby immediately a resource is created and you check the role assignment, the role-based access control, you see a service principal already inheriting a role assignment from there. So the third resource here is the actual ACR, so which you have the Azure Resource Manager templates for container registry, and then the desired name. You can change this to any name that suits you, or depending on the naming convention you have. Then you have other parameters. Parameters like the name, which is already initialized in the variables, resource group name. You have the location, the SKU. Sorry, can you hear me?
That's why when devil
Yes,
finish.
I can hear you.
Yes, we
I can
can
hear
hear you.
you.
Okay. Okay. So these are the variables that are required for the ACR, and then uh the last resource in this is the Kubernetes cluster itself. So this is ACR, Azure Resource Manager for Kubernetes cluster, and then you name the parameters. These parameters, there are ways you can, if you in a situation whereby you are just running a simple test on your local environment, instead of going the route of the variable, put initializing them in the variable also, you can just put the name, your desired name here, your desired location here, your desired version. That just equals to, and put a parenthesis, and put a quote and type the name you want. So, but initializing them in a variable part is more of a best practice and will help people to understand, or maybe engineers inheriting the code to be able to maintain the code. So then the default node pool, we have system, and then we have the node count. Depending on the workload or the capacity, just as in my colleague promise stated initial on, that the capacity of your AKS. So depending on the workload you want the AKS to carry, you might decide to increase the workload or decrease the node count, or increase the node count. However, before or after deployment, you can still put auto scaling. Like here, there are some parameters I commented out. So you can enable auto scaling, which in a situation whereby your node count, if your node count is 2 or so, then at a certain threshold or CPU utilization, the auto scaling will increase the number of your node count on the background without you having to interfere with your code or trying to make modifications on your code base or the infrastructure already deployed. Then the identity tab is system assigned managed identity. Then we have the network profile. So basically, we have two major network profiles in Kubernetes. We have the Kubernetes, and then we have the Azure. So the Azure is just more or less like, if you are referencing Azure here, it's more or less like using a CNI, which is a yes, Azure container networking interface. So, but the default for Kubernetes cluster is kubelet. Then for the load balancer, we're using standard. These are just network plugins that will help communication within your Kubernetes clusters. So as I'm going to the second file now to explain what it means again. If you have a question, you can either ask me directly by just raising up your hand from the team, so maybe you drop that on the chat, and my colleagues will draw my attention to that place. Then on the output, as I mentioned earlier on, the essence of using this output is to extract some useful information from the resources that you want to deploy. Once these informations have been extracted during deployment, you can reference them on other resources, like in the case of ACR, which we reference the ID of the ACR to Azure Kubernetes cluster. So this reference, the output to make those parameters or the information ready to be consumed by other resources during the deployment. Then the providers. So here basically providers just enable Terraform to interact with different services or APIs. So with providers, you'll be able to point to a particular service that maybe I'm using Terraform, which is a multi-cloud infrastructure as a code tool. So, and I'm using that on Microsoft Azure. I can reference AWS. I can reference GCP. So, but for this purpose of this, we are focusing on Microsoft Azure. So our provider should be Azure Resource Manager. And then the feature block here, which is empty, is just like a placeholder that will just be for future uh, references. Like if you want to integrate different other providers in the future, then this placeholder will serve that this where you have to integrate all these future providers. Then I have a skip provider registration. During deployment, basically Terraform will try to access different provider registration in your Azure portal, and then when that fails, or maybe you don't have permission, or as a result of those resources not being not registered within your Azure portal. For instance, if you have Microsoft.compute, which is a provider for virtual machines and the rest, Microsoft.web, which is a provider for app services and the rest. So depending on the resources that you want to deploy, if you want to skip this provider registration check, because this aspect doesn't actually register those providers, but it's just to run a check if those providers are actually registered on your environment before the actual deployment. So to reduce time that it will take for this to run, yes, I just added the escape, which you can leave it to false, and then it will run through all your Azure resources and check whether all the necessary providers are registered. However, even if you skip this and those resources and that you're about to deploy, some of the providers are not registered, it will fail. And the error message will be making reference to an unregistered provider. So what am I trying to say? This particular code reference doesn't really make the code to work when there is an error, or maybe when the provider is not registered. It's just to skip some steps and hasten the deployment process where I was testing. So currently the required providers we are using now is Terraform, HashiCorp, and Azure Resource Manager version 2.390. So if we have different other resources like GitHub, other application programming interfaces that we are using, we can start adding them, adding their code blocks here, like GitHub and the rest. We can start adding their references here. So it depends on how complex the environment or the resources you are deploying is. Then on the TFVers. Okay, here I will explain both TFVers and variables together, as they can be used interchangeably. Okay, starting from this, these variables are just used to a kind of define the configuration which are going to reference within the resource you are deploying. So here the variable.tf doesn't hold the actual value for the variables that you are referencing, except if you explicitly state the default value. So in a situation whereby you state a default value for each of the variable, then there will be no need to use terraform.tfvars, because you have also stated the value within the variable .tf. But the excess of using both is the variable.tf gives you room to give description of what each variable does. Say for instance that I've done this deployment and then it's very complex and another developer is inheriting this code. Within these variables.tf, the developer will be able to look at each variable description and know what that variable is for, and then check at the variable type and know the kind of the variable type, what it accepts. So in this situation, most of this we use string. In some, you use integers or number. We have to use boolean. We can use object and the rest, depending on the configuration of the resource you want to deploy. So the variable.tf basically gives you a general overview of what the variables you have and what they actually does. Why the terraform.tf verse or author.tf verse gives you the actual value and is arranged like in a key value pair, the key being the name of the variable. For instance, in this resource group name, if you come to the variable.tf, you see a resource group name. For this location, you see that here. So the key for this terraform.tf verse represents the variables which you have declared in the variable.tf, and then the value is the actual value that you are assigning to those individual variables. So the major benefit of this is in a situation whereby you have, let's say, hundreds or thousands of resources, like in some environments that I've worked on, you see thousands of auto tier values. So this will be easy for you to using Terraform.tf will be easier for you to track each key value and then make modification direct to it and understand what they are used for within the description of the variables. So you can use either of the two. You can use variables and assign a default value to it, but the best practice is to have these two so that this will just list the key value pair, and then the variable.tf will give you a vivid understanding of what each one does. Then going to the pipeline file. With this, without the pipeline file, I can run Terraform init, Terraform plan and apply, and deploy direct from this Visual Studio Code to Azure environment. However, we want to automate it again via Azure CICD pipeline. So here is the YAML script for that. Then I will explain this YAML script. Okay, good. So this YAML script is a multi-stage pipeline script to deploy this infrastructure to Azure. There are a few parameters or variables that are required for you to run it. For instance, as I finish this here, I can just start my Terraform init, plan, and apply, and it will work. But via a pipeline, there are some basic parameters that are required or variables that are required. One is service connection. So you need to have a service connection between your Azure DevOps environment and Azure Cloud, where you are deploying those resources. If you are using Azure DevOps for other cloud service provider like AWS or so, the service connection should have a line of sight permission between the Azure DevOps environment and your desired cloud provider. Then the second parameter that we use here is the agent pool. So in Azure DevOps, we have two options. You can either use Azure Pipeline Agent being managed by Microsoft, or you can provision your own VM and deploy an agent pool for that particular pipeline in it, so that that VM will be used to run each of your jobs. The advantage of using your self-hosted agent is, unlike the Microsoft hosted agent where a lot of people use it. So when there's a lot of jobs running on Azure hosted agent managed by Microsoft, in most cases you experience a bit delay for your job to run because those agents are being used by other jobs from different other locations or different other environments. So by having your own personal agent pool, then you'll be able to just manage your deployment and manage your jobs whenever you want to run your jobs. And then you can put a custom configuration to your own agent and put another level of security to it as well, unlike the Azure managed agent. So on this, I think we have done a series on creating an agent pool, yeah, and also but I'll just give a walkthrough of that here. So if you want to create agent pool on Azure within your organization or within the project, you come to the project setting, go to the agent pool. Yeah, we have a lot here. You can add agent pool and then follow the process. There will be, if you do a new agent pool here, yes, you have a code block that you have to run within your Linux environment or Windows environment, depending on the use case, and then the machine will be provisioned here and you'll be able to use it. That is one. Then the second thing here is the variable, which I think I've already explained on the variable on the backend.tf. So the backend.tf holds the state information where the Terraform will store its state. So on the pipeline, we initialize this as variables so that your pipeline will be able to know, okay, this is a particular state I want to deploy these resources. Also, there is a different way you can achieve this. Instead of in a situation whereby you have thousands of variables to initialize, instead of writing them all within this code block, you can use variable groups in Azure DevOps. With variable groups in Azure DevOps, yeah, that's I think, yeah. With variable groups in Azure DevOps, you can initialize thousands or hundreds of variables, and then within your code block, you can just call the group name. Let's say, for instance, I have a group. So I just called test group. So if I created a group here named test, for instance, test group. Sorry. If I have a group here named test group, and then add a lot of variables in here, immediately I call this, it will make reference to even thousands of variables within this place. And the good news there is you can lock each of the variables to hide its value, unlike having the variables displayed within your code base. So then this is about the variables. Then the trigger. So this trigger shows you, okay, what part of the JIT branch you want to trigger the deployment. So if it is automated or manual trigger, each of this branch, once there is a push on it, then it will automate the pipeline to start running. Then the first stage. The first stage is to build the Terraform, to install some dependencies like the Terraform versions, and then initialize Terraform within the working directory. So first we have to initialize Terraform, and this is the Terraform version we're using. We have to install Terraform, and this is the Terraform version we're using. Then the second task is to initialize it. While initializing the Terraform, you have to specify the directory where your code base is. For instance, here is the dev, this is the dev here, but this default working directory represents the default working directory of your Azure DevOps environment, and then this dev referencing the file that, depending on your folder structure, you can keep on increasing that here depending on your. Then if you just push your code directly to this default working directory, then there will be no reference for the dev. Then you just move on. So the backend type, you have Azure Resource Manager, and then we have to now add those parameters that will initialize or needed. One is the service connection. The backend and service, which represent the service connection, we have initialized here. Then we have the backend information, which is the container resource group name. We have the storage account. Then we have the container inside that storage account, and then we have the key inside that storage account. Then allow telemetry. This is just like log analytics. So to get more logs from this deployment, then you allow that to true. Command options. Upgrade this command option. This is used when maybe in some situations we are using an obsolete Terraform version or so, and the different modifications were made is requiring a new version. So doing this Terraform init, this command option is allowing Terraform to update all the necessary dependencies and versions that to suit the code structure that you have in place. Yeah, the second task is the Terraform plan. So this Terraform plan now, you also make reference to your default working directory, the service connection, then and then this will give you an output, a general output of what you are to expect or what resources are to be deployed in Azure portal. So if there are ones that need to be updated, it will show you. Then there are ones that need to be added afresh. Yes, the Terraform plan will be able to display all those details, and then we'll be able to review that before apply. So command options, you look for, yeah, this command option, we are using it to output this Terraform plan to output.tf plan within this same directory. So publish the artifact. That is, after this output, it will publish it within the same directory, which is default working directory -dev. Then this is the name that we just outputted here. So it will publish this artifact here. In some scenarios, if you want to do this, the last task here and just deploy, do your Terraform apply, it will work. Then, but to follow best practice, it's better use a multi-stage, let's say stage 2, so that after this you either implement auto approval or an approval from a tech lead or your colleagues also. So at this stage you can implement an approval so that once the Terraform plan is done, then it will send a notification or an alert to the admin group that needs to approve that, so that they will review the output of your Terraform plan. And then once that is approved, then it will trigger your deploy stage, and then the Terraform will deploy those to the target environment, either Azure or AWS, or as the case may be. So here on the deploy stage, we're specifying the environment we want to deploy, the display name, the deploy infrastructure to this dev environment, and then the current TF plan, which I've outputted here. Yeah, this script, with or without this script, your apply will still work. But this script helps in troubleshooting to list the ls minus l or minus la, gives you the list of files within this directory to know whether you actually have the right information before they apply. Then you reinitialize your Terraform. Reinitializing this Terraform at this stage is just the same step like what we've done here. Because if you take note of this, this is the directory where we did our initial plan. Then as we pick the output, here is the yes, default working directory is dev. So as we pick the output, we might continue with the default working directory or change to a, maybe depending on your folder structure, deployment folders. All right. Then in that situation, you can reinitialize your Terraform. If not, you can just go ahead and apply, and the initial Terraform that you have initialized will still take effect, because it's the same command and the same variables that we have in place. Then the final stage is just apply. Apply this here. this service connection to Azure and then apply the output of this Terraform plan to Azure resources. Once this is done, you can check your Azure environment and see if those resources are actually deployed. That is using pipeline. Okay, now on local environment, I will do a quick test to do a Terraform output, a Terraform plan output. We review that a bit and then we round up with the pipeline. So first, I'll do a Terraform init. Note that before you do a Terraform init, within this terminal, you must have logged into the Azure portal. So you do AZ login and it will take you directly to a browser, your default browser, to sign into your desired Azure portal. Then before you can run init, it will now deploy. So the second command is we will run Terraform plan. And then this should be able to give us the output of what we're trying to deploy to Azure environment. Okay, here we go. So when you run it, just like in the pipeline interface, once you run a Terraform plan stage, you have a different uh, outputs here. Any output with a plus shows a new resource to be created. Then you see a yellow hyphen, it shows a resource that is being updated. And then you see a red, it shows a resource that will be deleted on that target environment. So this is a new resource that we're just deploying for the test. So as you can see, everything is just plus. So if I run my Terraform apply now, it will deploy this. If I run Terraform apply now, it will deploy this to the target environment. But I won't deploy that straight so that my colleague Nacho will do the deployment via Azure pipeline. That's to achieve the essence of automation. Because once you do it this way, the automation is more or less like a halfway. So we have done a script to automate an infrastructure, but we are still running some manual code to be able to deploy that. So the automation is not fully complete. So I will be at this stage, I will be handing over to my senior colleague Nacho to walk us through on the pipeline interface and then how to deploy this pipeline to Azure environment.
Awesome. Thank you very much, Debere. Nacho,
Yeah.
yes, you can proceed.
Hello, everyone. Thanks for the time. So I'll just continue from where my colleague Chidi stopped. So virtually we've gone through everything we need to do. So right now, this is Azure DevOps services, and we're using the pipeline, like Chidi explained. So we have the same code he has run, same pipeline file here. So we are going to just try to point to this pipeline and have the sequence of events run through. We'll be having two stages. Terraform build stage, which of course that installs Terraform version 1.83 and initializes the module from the configuration block for dev directory. This initialization will of course bring in the plugins, downloads all the plugins required, probably check verify the backends are intact. Like I explained, the backends are where we'll store the state file, which is already here. Okay, so without wasting much time, I will try to run through that pipeline and we'll get to see what really happens with that. Okay, so we'll go to creating pipelines, selected GitHub, which is where my repo exists, is being hosted in. Then I'm going to select existing Azure pipeline YAML because we are trying to use this existing one. We're not creating from scratch. We're pointing to this particular one. So what that means is we're going to select and we'll navigate to where the pipeline is, where it is on the pipeline, which is on the home directory, right? So name of the file is azure-pipelines.yaml. So we'll pick this up for our use. And we have the same YAML file for a pre-review before we can run the pipeline. So just to clarify that the backend has initially been created. This was created manually because it's a case of prerequisite needed to bootstrap Terraform. So just to walk you through this again, the backend already defined in the backend block of Terraform uh, is also being defined by what we call an extension tags here using Terraform version 2, Terraform CI version 2. So it's going to be having, it has the service connection, which is, of course, your application user, just like Chidi did on the CLI trying to use easy login. So this authenticates Azure to Azure DevOps using its underlying service principle. So the Terraform resource group, the storage account name, the container name, and the key. So if we go to our variable, we already defined the storage account as IAC Boots Lab, which is this. And when we open the storage explorer, you see the container blob, which is tf state-demo. Okay, so this is where our Terraform state file will be hosted in, we will live inside. So with this, we can, I believe we've been able to just highlight that explanation again. So I'll hit the run button and see what happens. So we're expecting it to create the pipeline and start to run this. And like we mentioned, we have two stages. The first stage will view Terraform. What we're expecting, it checks out to this repository. It installs Terraform with that extension, Terraform CLI extension. Then it initializes the directory, which in our case would be the dev directory here, which houses the configuration for Terraform. Okay, then it executes a plan information from the code. If we'll come to the pipeline, we'll see that plan information is right here. Okay, so what does it do? It's saying, it gives us a preview of what will happen. We will be expecting a container registry to be created. Like I said, will be created. We'll have an AKS cluster to be created as well. It's all its configuration originally defined in the configs. Okay, we have a resource group created. Resource group name will be demo AKS. We have the role assignment created. Of course, this will allow deployments to the ACL, the container registry. That's the pool access. So we have other configurations. So this will create 5 resources, new resources. So this is what the plan information does. So this extension helps visualize those overview, or we'll have preview of the deployment. So now, like what Chidi has explained earlier on, we have this deployment tied to an environment, and this environment's name is dev. Okay, so this kind of allows us to set different permissions or approvals, kind of course, in an ideal state, you don't want to do this for a dev. maybe probably for UAT or for production. But yeah, we are doing this just to demonstrate that we can have such approvals, and we have approvals set for whoever is required to approve this deployment. And what does that mean? Say you have a release or a change manager. That person is in charge of coming here to understand what the Terraform plan output, if it's desirable, if it's not, if it doesn't meet the criteria for deployment or for a release, the change manager can decline approval. But if it meets the criteria, then of course that will be approved, and depending on how the organization handles, probably there will be some form of communication as well to stakeholders. So that's from what we see here. Deployment is waiting for approval to deploy that Terraform change. So we're going to here. I'm going to assume I'm a release manager or a change manager. I'm going to try to approve this. Of course, I've gone through the plan and I say, yes, this is desirable output. Then alone, I will approve. So why this is approved, it will move from the build stage to the deploy stage. So again, similar stuff. We'll see the jobs. First of all, we see the download of the artifacts, which is the Terraform output from the build. Okay, and the reason why we are doing this is we want to ensure that the build is exactly the same result with what was built from the Terraform plan from the first stage, which is the Terraform build stage. So of course, that plan is what we moved from what we call the staging directory. Okay, move that output file to the deployment directory, which will be same default working directory, which is essentially this configuration file. If we take a step back to our file, we'll see that so it pushes this plan, or it pushes this output plan to as an artifact named TF plan, pushes that and allows it to be available for every other build stages. And for this second stage, we're going to be downloading that particular artifact, container artifact. We'll download that, and this will be downloaded to the pipeline workspace or the Artifactory default directory. They are similar, they are same directory actually. So then we are trying to move that from that general directory to our own directory where we'll be working on, right? This is why we have done this, and from here we can simply deploy that output that plan. This is what we've done. So if we go back to our pipeline, this will still be running because, of course, it's AKS is deploying a lot of resources. Let's go and see what's happening. We'll be expecting a new resource group, which is the demo AKS resource group. So it's creating the cluster and its associated resources. So we have the demo AKS CICD container registry. Okay. And it's still provisioning because we are expecting a default resource group, which will be where our worker nodes will be deployed into. So that will come up very soon. Once this deployment is over, we'll see additional resource group for that. So it's still running. Why this is running, I would just like to share a few things. Like we talked about extension. So to actually install an extension, you have to go to the organization level, go to the settings and look out for extensions. This is where you probably want to browse and select a particular extension you want to install and make available to all the projects beneath this organization. So this is how we are able to install Terraform CLI extension that you see available in our pipeline. That's this one. Okay, this is how we're able to install this for use. So that extension made all these stacks available for use. So this is that. And again, why this is still running, because that will take a little bit of time. We can also try to make this pipeline a little bit more desirable because I forked this project from our Azure support repository. So it's actually now on my own repository. So it's going to be having a default name, which is like the standard. So we'll try to rename this to something more identifying. Say we can call it, say, Azure Kubernetes infrastructure deployment. Let's so this way we know for sure that this is our pipeline and have an idea of what it does. So we can have different standards for naming pipelines in different organizations. So yeah, so that's the one. Yeah, that's fully deployed now. So let's see what has happened here. Sometimes it takes a little bit of time for it to shoot, but so we have the AKS running. So this will have all the properties as described in the code. Resource group, the AKS version, and other dependencies as defined in the code. This all will be appearing here. Right, so that's really an overview of what we have done. So this is our AKS. We can want to say connect to it and and play around with it. But basically, this is our infrastructure. It has been deployed. But I'm also expecting a default resource group for AKS resources. I'm not seeing that yet. Probably some portal delay, latencies. So that's really that. Do we have any questions? Any questions while we are waiting for everything to come up?
Yeah, I don't see any questions for now, but I see Aldo Zachary, I see your hands raised up. Maybe if you can unmute yourself, you can ask the question you have in mind.
Yeah, please, Zachary,
All
ask.
right, please confirm you can hear me.
Yeah, I can hear you.
Yeah, good evening.
Good evening.
Yeah, thank you very much for this wonderful session. And I actually joined very late, but I can confirm to you that I enjoyed each and every bit of the explanation that both Ianacho and Juliet have given to us. So what I want to ask, right? Since because I know that for IAC, what we do is we use it to deploy infrastructure, right?
Yeah.
So In the process of deploying this infrastructure, is it possible that there can be a kind of a vulnerability that might occur, or since it's just setting up infrastructure, there's nothing like vulnerability to look out for?
Hmm. That's that's a very good question. That's a very good question. So in terms of vulnerability, I mean there are infrastructural vulnerabilities as well, and I want to say this in terms of, I mean, you could have a configuration that is not so secured, and it becomes a vulnerability, right? Say for instance, you are actually having a public access to your resources in itself, so it becomes a vulnerability. And
Oh,
there's this Azure shared responsibility that has actually defined what you're responsible for as a client and what Azure is responsible for. So that alone, in a sense, can introduce the vulnerability. So probably you're having, say, weak passwords or bad practices. Of course, that's also a vulnerability, right? So in its sense, I won't say there's no vulnerability. Okay. Then also there can also be some other, because really what really happens with Terraform is we're having a lot of API calls, right? And eh, I mean the open source community works on improving things there and there all the time as well. So there are reasons why there are updates to different versioning and things like that, right? There can also be a little bit of better way of doing things. Say, for instance, there are a time where we don't have a sensitive variable, right? Then it also was introduced, right? Because we don't want the password, the sensitive things to just be displayed somewhere. So to answer your question, there are vulnerabilities in even in infrastructure deployment. There are, but it depends on your perspective, the way you look at it. There's always vulnerability. Yeah.
Also, to add to
all right.
what my
Thank
colleague
you.
said, some of the things you do when working with, let's say, automations like this is to avoid, let's say, secrets leaking, to avoid, let's say, some of these vulnerabilities my colleague has mentioned. You have to do what I would call code vetting, right? There are tasks you put in your Azure pipeline to scan for secrets being exposed, to scan for improper codes. In fact, there are implementations you put in place to ensure that you are not even allowed to commit your a code that is not properly written. There are things like, I don't know if you've heard of things like pre-commit. You could do a lot of pre-configurations on your desktop or your agent running machine, right? These pre-configurations help you to do help you to check for default things, probably things like spaces, things like error in your password, or let's say a secret leak. You understand, when you have configurations like this set up in your Azure DevOps environment or in your local environment, then you are able to battle things like what we call all these configuration errors, or let me say um, issues happening that are not meant to happen, right? So that's how you go about resolving issues like this. Ensure that you have proper configurations to check, to ensure that these checks are being made, and that there's no will I say there's no way that something could creep into your system. Yeah, thank you.
Yeah, so just to add to that,
Okay.
one of the things we can also do to improve things is having, like Promise mentioned, pre-commits. We also have, sorry, we also have things like configuration check for Terraforms. That of like Terrascan, checkups, Trivi, Sneak. There so many of them. Okay, what it does is they look at the Terraform codes, not just as code, but also as an infrastructure, and kind of analyzed what you have put in place. Okay, so it gets to have a level of severity in your vulnerability or exposure. So you can want to say, for instance, if it's a critical vulnerability, this shouldn't pass. Stop the pipeline, right? Halt the deployment. So you could have things like that. So you could say, okay, for very low severity, you could skip that kind of, you're not concerned about that kind of vulnerabilities, right? Say for instance, it could be a configuration advice. For instance, probably you have a good reason why you should skip that. Say for instance, probably that configuration is not even valid for you, right? So things like that. So yes, that's very very good to mention. So I have to just make sure I have you checking that as very important stuff to do. So I see
Thank you very much
Emmanuel.
for the feedback.
Yeah. So Emmanuel has a question. Your hand is raised up.
Yes, I do, and I want to thank you all for the section. It has been quite informative and enlightening too. Okay, so I just have some few questions and also a request that I also want to make. So possibly I can just start with the request, then proceed with the question. Okay, so I would want to know if it would be possible, because for me, after now, I would also want to reproduce what we've done on this call. And I don't know if it's possible to also share like the Terraform scripts that was used. Yeah, you can remove the environment variables and the rest, but just something that can give a guide on case I run into any future error, and I can possibly have something to fall back just to review. So that's just one of the requests. And a quick one for the question. I just want to understand because I've not really used Azure DevOps. That's in terms of the pipeline to deploy Terraform scripts. So I want to know. I don't know because for GitHub Actions, I don't know if it has almost similar working operations or procedures, because at a point where you are using your VS Code and you've already set up your repo, okay, and so I want to know if it is possible to uh, when immediately you commit, okay, that Terraform script directly from either of the test editor, like in this case VS Code, whether the automatically the pipeline will pick it up, or is it a must you have to go to the pipeline, that's the Azure DevOps, and run it manually? Because I noticed that was what's uh, happened in this scenario. So that's just what I wanted to clarify.
Oh,
Thank you.
okay. No problem here, Natural.
Yeah.
You add more to it. That, well, let me just give you a quick overview. Thank you, Emmanuel. So, with respect to your question, yes, as I mentioned while I was explaining the code on triggers. So, if you set up your triggers on the pipeline, so during the pipeline creation, you put automate it, and then instead of manual intervention that whenever a code is pushed, then you have to trigger the pipeline manually, you can automate it that once a push is coming from this particular branch, for instance a main branch or master branch, immediately there is a push, then it automatically triggers the pipeline. So in
Okay.
that situation, you don't have to manually come to the pipeline to trigger that. So, but before you go ahead with such scenario, then there are some other configuration that need to be put in place, like approval checks, right? So if you have approval checks in place and then multi-stage pipeline, so that once it gets to a Terraform plan stage, then it can trigger an approval check that another person or your team lead or any of your colleagues responsible for that check, we'll be able to do a thorough review of the output and confirm everything is fine before then the final approval for deployment.
Okay,
So,
that's good.
so those checks need to be in place before you implement it. Okay, good. Also, I think Ian, Archer, please should share that screen and throw more light on that again.
Yeah,
Thank
okay.
you.
Let me so this is the trigger,
Yeah.
right? That Ugo mentioned. Okay. So we can have, say, a trigger to what we had here was to main. Okay. And because we didn't push any code, okay, so there was no code change for it to have actually triggered. That's why I had to run manually. So what this means is if there's a merge request to into main, okay, this pipeline is expected to run. So if my colleague asks us to do a little bit of changes, maybe we could just add the kind of any force change here and see what happens really.
Okay, just the count, the node count.
Okay, maybe I could just do a force change.
Add anything. Okay, good.
What can we change here? Now just change your name. Force change. Not really change. Of course, we won't be committing to main like this in a decent
Yeah,
environment.
yeah,
Okay. Yeah, you
yeah.
see, it's running. So what should happen initially should be probably some mix a change. Code is being reviewed. There's a merge request. Then it's being merged to main. That should be the process ideally. So once that is being committed, the trigger, because it says if there's a change to main branch, just run. It runs. So like Chidi tried, also pointed out to you that there could also be ideas where we need to like do like an approval process, like he mentioned. Okay, so it halts the deployment and wait for someone to approve it, even after it's been meshed to that same main. Yeah, this is kind of actually an Azure DevOps demo, but just like Azure DevOps, there are also triggers for um, Git
GitHub
actions.
Action.
Yeah, like we have in this kind of pipeline, similar the same stuff. Okay, we are using this on syntax to define same stuff. If there's any change to main branch or bicep branch, just run this workflow. So similar stuff, kind of. But yeah, this is not a GitHub action demo, so we won't be able to say much about that.
Yeah, I understand that. Thank you so much.
Yeah.
Ian Acho,
I think
I
someone.
this is coming if as a form of request, please. I don't know,
Yeah.
probably after this session, if you and your team can just share maybe a link or any kind of material that will help us expand further on what we have learned from here, please. That would be appreciated. Thank you.
Yeah. Thank you, Samuel. Promise, have anything to say to that?
Sure. Of
So,
course, we will share some details with you. I don't know if you all are part of the our LinkedIn group, the WhatsApp group, and um, our meetup page. So I would advise that you join one of those groups so that we can be able to share files like this with you. If you are not following our page, follow our page on LinkedIn and just send us a chat or something, and we'll be there to respond to you.
Yeah.
okay, can you share the link? Can you share the link for those social media handle you've spoken about?
Yes. I'm going to share that right now. And also,
Okay.
if you look at this chart, there's is a GitHub repository which all the codes Chidebere has explained, and the pipeline is actually there. So feel free to fork and play around with it. So yeah.
I
Okay.
can't see the
Thank
chat
you so
from my
much.
end. I don't know. I don't know. Probably it was because maybe the message was pasted before I came in, but I can't see the chat from my end.
Does anybody see any of my chats? This ones?
Okay, so for me, that's also what I wanted to say. I cannot see the chat at all. So I don't know if I'm just the one, yeah, not seeing that. It's just throwing up an error, having trouble loading your
Okay,
messages, blah blah. So I try.
maybe
Okay.
Yeah.
what we can do
Yeah,
is
same error.
that I don't know, Chidebere, I think you were able to share these links, right? Or
Yes.
better still, Chidebere can share those links on the page, and also you could go to LinkedIn and check our page. But I think it's just a minute. Let me confirm the name of the page. I think that would be the
Is
easiest to
Azure
reach.
Infrastructure and DevOps Support Community.
Exactly. So you could search for that Azure Infrastructure and DevOps Support
Okay.
Community, and you will see our page, right? Now, once you're on the page, you can be able to send us messages and we can reply to you from there.
I think one of the posts on that page has our WhatsApp group that you can join, and then on the WhatsApp group we also share links directly, and you can ask questions there as well.
Thank you so much. Yeah. I'm already on the
You're
WhatsApp
welcome.
group, so I think I'm following almost on all platforms. Yeah. I really appreciate the work you guys are doing. So
You're welcome. So, any other question, please?
Yeah.
Yes.
Hi. Okay.
Okay.
Someone proceed, please.
All right. Good evening. Thank you very much, Chidebere. Thank you, Hanacho and Promise for the section. Is quite informative. Um, actually needs maybe an idea into managing um, our pre-existing infrastructure. I actually joined my organization recently and I started using um, Terraform to manage and provision infrastructure. Before joining, they have a pre-existing one they actually runs, and I'm now thinking of importing them to into my current workflow. I don't use Azure DevOps. I use GitLab. My pipeline is on GitLab, and I'm concerned about how I'm going to handle these importations and then manage the state without conflict. I don't really, I don't really know how best to go about that.
Chidi, you want to give us some
Okay.
hands on?
Okay. You mentioned that the pipeline is on GitLab.
Yes, it's on GitLab.
Then your target cloud environment is Azure or
It's Azure.
AWS? Is
Yes, it's Azure.
Microsoft Azure. So probably
Yes.
your TF state should be in Azure.
No, it's not in Azure. GitLab actually have a backend
Handles that a backend.
handles
Okay.
that. Yes, yes.
Okay. So if I understand your question correctly, there is a change management that you would like to import to the existing workspace you are working on. Am I correct?
Yes, yes.
Okay. So
And most of this infrastructure actually are client who host client facing applications. So I don't want to break anything. I don't want to.
yes, yes. At times it happens that way. But do you have something like a dev environment, or maybe you run it locally on your local machine and see the output of the Terraform plan, and then see if maybe there are some modifications you need to make, updates or importation you need to do? Have you tried that locally on your machine?
Like what works currently, I've used it to provision infrastructure that is even currently live and it manages some infrastructure already, right? But
Okay.
I'm thinking of bringing in the other pre-existing one that are not already being managed by
Managed by
Terraform
Terraform.
into it. Yes.
Okay, good, good. Yes, then in that situation, basically, what you need to do is to import those existing infrastructures into your Terraform modules.
Okay, so what do I do to import them? I actually utilize I use Terraform modules to provision my infrastructure, and then what do I need to do to start importing them?
Okay, there's a resource import for existing for existing resource in Azure that you can. I will need to do a quick check that you can run to bring in those existing resources into your local configuration, and then you can now push that to update the Terraform state. But I will need a confirmation of that just a few minutes.
Okay, so
Oh,
why Chidi tries to confirm that? Yeah, so Samuel, right? Sorry, what's the name
yes,
again?
yes, it's Samuel. Samuel is
Samuel.
his name.
So yeah,
Yes.
that's my name as well. So really, when it comes to some config that already exists but not on Terraform, you have to import that state. Okay, and Chidi will share that. How do we share that command? So he will get that command here, which simply tries to make what you have on Azure uh, portal and pull that configuration to your backend. That's what it actually tries to do. So
Okay.
whether it's Azure DevOps, whether it's Git Actions or GitLab, that's not a concern for me right now. But if I want to do similar stuff you want to, so first of all, for those resources that already exist, you have to import them one after the other. Okay, and try to, if you are using modules, good. You can also, there's a command to install um, import with module as well, but it's still gonna be single resource per command for that
Command.
importation.
Okay.
So
Yes.
once you've imported that, you try to at all times try to do something like a plan and compare if you have a zero no changes. That's what you try to achieve. So you keep on making those changes to your code till you have a zero no changes, right? So
Okay.
you just need to import this to your back end, like we did now in this demo. We use a storage account, right? So say you want to do the same thing.
Yeah.
While you do your Terraform import, make sure you have your backend configured, and at one point or the other, you can as well, list these states you have, check the configuration with what you have configured, and see if it matches. So that's like a lot of process to just define, like with this simple
Yeah.
answer. So
Yeah.
probably
I
we'll need
understand.
say another demo session really to break
Okay.
that bit
To
by
manage
bit.
That will be
those.
fine.
Okay.
Yeah. So I
That
don't
will
know
be
if
fine.
Chidebere or Promise can
Yes.
help us with something of that kind of nature. Then we
Yeah.
can go through it one after the other, and that will really help you.
Okay. I can't really drop a chat here on this interface. I don't know if someone else is experiencing it. Yes, but from my confirmation here, what you basically need to do is each of those resources, you have to define a resource block for it, and then run a single import command for that resource. So if, for instance, you have 100 resources not managed by Terraform, then you have to do it that way, which is a whole lot of work.
Wow.
So, but I
That's a
can't
lot of
drop
work.
a code block here on this chat interface, but I think we need to do a session on that. We
All
need to
right.
do
That
a
will be
session
fine.
on that, and all of us will have a walkthrough on it, and then you understand it better.
That will be fine. I will really appreciate that. Thank
Oh,
you.
you're welcome. Okay, please, any other question, please?
I think we've actually gone past our time now, so maybe I think it's the best to round up so we don't
Okay.
keep everyone waiting. And of course, we have some other subtopics planned for this session. So we want you to stay tuned and look forward to our next session, which we have planned for you. So at this point in time, I would like to say thank you everyone for
Sorry,
taking.
promise. Sorry, promise. Sorry. One last question, please.
Go ahead.
I really don't want this session to end.
Okay.
Please, I just want to, this is a quick one, right? What happened to the state file after deployment? Probably maybe a changes has been made to the YAML file after after the infrastructure have already been deployed. What happens?
It will be updated.
Yeah,
Oh,
so
it
when a
can.
change is made and you run it, the change that you have just made is only that change is executed and updated to the state file. So it's like a what's the word? Continuous addition, right? So Terraform doesn't do anything for anything it has existing. It only acts on the change it sees, and then it implements just that change and add the current situation of things to the state file. Now, the issue some of the times is that some people go to the actual application and make changes from the application or the infrastructure without going through Terraform. Now, at that point in time, Terraform sees that a change has been made on the infrastructure without using Terraform. Um, Now, in such a situation, what you then have to do is to import the change you made in the application or the infrastructure. You need to import that change into the state file. When you import that change into the state file, then Terraform is aware that that change has been made. So yeah, those are the processes Terraform state files use to manage changes.
Thank you very much. Thank you. I'm sorry for wasting your time. Thank you very much for that
No,
Not
answer.
it's
Thank you.
not
not
wasting
at
Yeah.
all.
time.
All right. Like I said, at this point in time, I think we can close for the day. Yeah, guys, look forward to our next session. Thank you very much, Chidebere Ogu. Thank you very much, Ihana Chochuku, for sharing your awesome knowledges with us. We are really, really happy and grateful for this. Yes, we look forward to the next session and we hope to see you guys. Thank you very much.
Thank
Cheers,
you,
guys.
everyone.
Bye
Yeah.
bye, all.
Thank you,
Thank you
everyone.
very
Bye.
much.
Bye.
Yeah.
All right.